All right, in Concept T, we're going to be focusing on what makes a reaction spontaneous, some factors that contribute to this. So spontaneous chemical changes are going to proceed on their own once they have begun. Spontaneous reactions is one that can occur under certain specific conditions. So in order for a chemical reaction to be spontaneous, there has to be a balance between two factors: enthalpy and entropy. Enthalpy we already talked about, so we're going to just review that and then speak about entropy. So enthalpy is the energy content of the system. Nature favors reactions that undergo a decrease in enthalpy. So enthalpy is also considered the potential energy of the system. So we want to decrease our enthalpy or decrease our amount of energy. So generally systems that go from higher to lower energy states or exothermic reactions are more likely to be spontaneous. So we like to think of spontaneous reactions as being ones that are lazy. They're getting rid of energy and kind of relate that to our exothermic reactions. Most endothermic reactions are non-spontaneous. They require a constant input of energy to keep them going. All right, entropy. This is a new vocabulary term. Entropy is a measure of the disorder or randomness of a system. Nature favors reactions that undergo an increase in entropy. Systems in nature tend toward disorder. So the higher the disorder, the higher the entropy, and that is more favorable. So think about your room. Okay, in order to go from a messy room, you need to put in an organized effort requiring energy in order to get it clean and organized. However, in nature, things tend towards randomness and disorder. So over time, without effort being put in, we have a spontaneous reaction where it arrives back at its messy state and disorder. So same thing here, entropy is an indicator of randomness. Low entropy, we have all the little beans separated and categorized. High entropy means high disorder. It's been shaken about, and slowly over time they become more randomized. Here's another example, especially with the bricks right here. If you toss bricks out of a truck, what kind of pile of bricks would you most likely produce? They're not going to fall into nice, neat rows. Disorder is more probable than order. So things in nature tend towards disorder. All right, so what are some ways that we can tell if entropy is increase or decrease? First thing is a phase change, solid to liquid to gas. Gas particles are the most randomized, so they have the highest amount of entropy. So in this reaction, we have a solid going and producing two different gases. So here we have an increase in entropy because, again, a solid, which has a lot of order, is being converted into two gases, which have a lot of disorder. We also can look at the side of the equation with the higher number of molecules or pieces. So here we're going to start with 3 particles, and then we're going to transform into only 2. So I actually have decreased my entropy because the number of particles are going to go from 3 to only 2. All right, and then an increase in temperature also causes a higher amount of entropy because there's more random motion of the particles. So if I have a helium gas at 300 Kelvin and I cool it to 200 Kelvin, I'm going to cause a decrease in entropy because the temperature is lowered, so there's less random motion of particles. All right, now, how do we put enthalpy and entropy together to predict if a reaction will be spontaneous? There's something called Gibbs free energy exchange, which takes into account both enthalpy and entropy, with temperature being a factor. So delta G, which is Gibbs free energy, is equal to the change in enthalpy minus the product of temperature and our change in entropy. Now, with regions, we're not going to actually be going ahead and calculating this, but you should be aware of the general characteristics of the equation. If delta G is negative, the reaction will be spontaneous under the specified conditions, which is one thing you do need to know and memorize. Some reactions are always spontaneous if enthalpy is negative and entropy is positive. This is going to produce always a negative delta G. Enthalpy being negative is exothermic. Entropy being positive is a gain in entropy, so more disorder. However, we should note that some reactions are not spontaneous at room temperature, will become spontaneous if heated, if we can change the temperature and increase it. All right, so the big idea, and I want you to write this down in one way or the other, is that things in nature tend to undergo changes towards, and this is referring to being able to be spontaneous when they have a lower enthalpy and a higher entropy. So when they want to be lazy and messy. So lower enthalpy, exothermic, indicating the laziness, and higher entropy, more disorder, indicating the messiness. All right, that's it. You are all set, and we'll talk a lot more about this tomorrow in class.